Brand new images of Interstellar Comet 3I Atlas just dropped, and they look unreal. An emerald green ghost drifting over Egypt, a deep blue core captured by a space telescope, and twin tails photographed by a spacecraft near Jupiter. All this while it races toward its closest pass by Earth this December 19th. The wild part about 3I Atlas is that the photos look like sci-fi artwork, but they're completely real. One long exposure image from North Africa shows the comet glowing like a floating emerald. Another shot from orbit reveals a compact blue core wrapped in a soft halo of dust. And from far out near Jupiter, a spacecraft has captured two distinct tails fanning out into space. As 3I Atlas rushes through the inner solar system, sunlight boils off gas and dust in uneven bursts. Some of this forms the classic dust tails sweeping away from the sun-charged particles stripped off by the solar wind, create a thinner, electric blue plasma tail. The colors shift depending on what each instrument is sensitive to. Earth-based telescopes pick up a cyan-green haze tied to carbon-based molecules, while space telescopes emphasize water, CO2, and dust, giving it a blue-white shine. Now for the close-to-Earth moment. On December 19th, 2025, around 6 o'clock Universal Time Coordinated, 3I Atlas reaches its closest approach at roughly 1.8 astronomical units, about 170 million miles, or 270 million kilometers. That's more than 700 times the distance to the Moon, and it will be on the far side of the Sun. So there is zero danger, but this is when telescopes get their best view before it fades again. How do you see it yourself? It won't be visible to the naked eye. Around closest approach, its brightness hovers near magnitude 11 to 12, which requires a serious amateur telescope, 20 to 30 centimeters aperture, plus dark skies. In mid to late December, star charts place it gliding through Leo in the pre-dawn hours, just below the bright star Regulus, low in the east to northeast. Through the eyepiece, it looks like a tiny, slightly fuzzy star. In stacked photos, that faint green coma and delicate tail suddenly appear. Visually, it's subtle. Dynamically, it's outrageous. A one-time visitor from another star system slicing through the plane of our planets on a retrograde, hyperbolic path tilted about 175 degrees to the ecliptic. That bizarre geometry is why observatories and spacecraft across the solar system are racing to capture it while they still can. If you could zoom out and watch the entire solar system, 3I Atlas would look like a celebrity walking a cosmic red carpet, with cameras firing from every angle. Every major telescope wants a piece of it, because this isn't just a pretty comet. It's a rare sample of material made around another star. From Earth orbit, telescopes have been tracking how its coma grows and twists. A recent image showed a bright core, a faint fan of dust peeling away, and hints of narrow jets. By comparing snapshots over time, astronomers can identify which surface regions are waking up, how fast dust is being launched, and whether the activity is smooth or eruptive. The asymmetry in the glow becomes a kind of weather report for an object racing through space at over 200,000 kilometers per hour. Far beyond Earth, a spacecraft near Jupiter captured both tails, one shaped by dust, the other shaped. Its cameras mapped the structure while its instruments measured how the comet's gas interacts with the solar wind. This combined view is rare even for local comets, and priceless for an interstellar one. Then there's the infrared view. Detailed spectra revealed water ice, water vapor, carbon monoxide, and an unusually strong carbon dioxide signature. The CO2 to water ratio is far higher than in typical comets from our own system, hinting that 3I Atlas was born in a much colder, more distant region around its original star, and that its ices stayed remarkably preserved throughout its journey. Radio observatories have also mapped methanol and hydrogen cyanide streaming from the nucleus. As the comet moved closer to the Sun, methanol production spiked while cyanide stayed nearly constant, creating an unusual chemical fingerprint not seen in standard solar system comets. Layer these perspectives together: Earth-based telescopes, spacecraft near Jupiter, infrared observatories, radio arrays, even orbiters around Mars, and you get the clearest, most detailed multi-angle study of any interstellar visitor to date. So what does all this chemistry actually mean? The short answer: 3I Atlas looks chemically unusual, even for a comet, and that weirdness matters. Between its CO2-rich coma, methanol-heavy gas, and traces of hydrogen cyanide and hydrogen sulfide, we're looking at a mix that blends the building blocks of life with molecules that are toxic in concentrated form. The ingredients are familiar, but the proportions are unlike anything common in our system. In typical comets, methanol and hydrogen cyanide maintain a modest ratio. In 3I Atlas, methanol production is off the charts while cyanide barely changes. This suggests it formed in a region where carbon-rich compounds were easily assembled, possibly a dense, cold cloud far from its original star. It may also have spent eons in a stable environment where cosmic rays could process its ices without destroying them. This is why scientists keep referring to ingredients for life. Not because the comet carries living organisms, but because it shows that life-relevant chemistry is widespread across the galaxy. Complex organics aren't limited to our Kuiper belt or Oort cloud. They seem to be a natural byproduct of star-forming regions everywhere. At the same time, 3I Atlas is a wake-up call. Space agencies had to improvise a global observing campaign with instruments never designed for interstellar comets. Future missions are already being planned specifically to intercept the next unexpected visitor, using 3I Atlas as the perfect case study for why we need to be ready. In short, this faint green smudge in Leo is forcing us to think bigger. Dynamically, it proves that icy fragments can travel freely between stars. Chemically, it reveals that some star systems overproduce complex organics. Strategically, it shows why we must prepare for future interstellar encounters. Taken together, 3I Atlas stops being that green comet in the news and starts feeling like a message in a bottle from somewhere else in the galaxy. The striking images, the emerald glow, the blue nucleus, the double tail, are just the cover art. Inside, the fine structure of its light tells the story of an object built in a distant, frozen nursery and then flung across interstellar space. If you're lucky enough to have a decent telescope and dark skies, December 19th is your best chance to see it. It will be faint, low in the east before dawn, hiding beneath Leo's brightest star. It will never look dramatic to the naked eye, but knowing what's inside that blur makes the experience unforgettable. If this discovery keeps your curiosity alive, stick around for the next interstellar visitor. And tell us your theory in the comments. Also, don't forget to like, share, and subscribe. Your support keeps our journey going. Thank you for watching. See you next time.